All right, so at the bottom of page 216, we're going to review solving by elimination, where we don't have to do much to the equations to get them to solve. So, Shane, do number 1 for me. Yep. Are your x's lined up? Are your y's lined up? So we're good to go, right? Do your x's eliminate? But the y's do. Good. So they go away because I have positive and negative of the same number. What's 2x plus 3x? 5x. And what's negative 2 plus 12? 10. So my x equals 2. Good. So my x value is 2. Which equation do you want to use to find y? The top one. So we have 2x, or 2, now we have a 2. We substitute that in. Plus 2y equals negative 2. So 4 plus 2y equals negative 2. How do I move that 4 to the other side? Subtract it. So 2y equals negative 6. What does y equal? Negative 3. Good. Okay, and since we used the first equation to solve it, let's use the second equation to check it. So 3 times 2 is 6, minus 2 times negative 3, also 6. So 6 plus 6 is 12, and that should check out. Yeah? Okay. Good. All right, number 2, Reagan. Are my x's and my y's lined up? Do one of those terms cancel out? Which one? The x's cancel out, right? Okay, good. So now what is negative 2y plus 4y? 2y. And what is negative 1 minus 2? Huh? Negative 3. Divide both sides by 2, so my y value is negative 3 over 2. Uh-oh, we have a fraction. Complete chaos will ensue. Okay, Reagan, which equation do you want to use to plug in? Say the first one, Reagan. There we go. Okay, 4x minus 2 times negative 3 over 2. Now, before you start getting all crazy and trying to do fraction busters, are we going to need fraction busters? No. Because what's a negative times a negative? Positive. And what do those 2's do to each other? They cancel out. So I just get 4x plus 3 equals negative 1. How do I move that 3 to the other side, Reagan? Subtract it. Good. So I get 4x equals negative 4. What does x equal? Good. Negative 1. Good. Okay. So let's use our second equation to check. So negative 4 times negative 1 is 4. What's half of 2? Or sorry, what's half of 4? 2 times negative 3. What's 2 times negative 3? Negative 6. What's 4 minus 6? What? Negative 2. So that checks out. Good. Sorry, there's not much room in these problems. Good, Reagan. Okay, number 3, Katie. Okay, so are your x and y terms lined up? Which one of those terms, do you have a term that cancels out? The y's cancel out because I have negative y and positive y. So when I'm done, what do I have? What's x plus x? 2x. And what is 2 minus 3? Negative 1. So x equals negative 1 over 2. Which equation do you want to plug into? First one. So x is negative 1/2 minus y equals 2. How do I move that 1/2 to the other side? You add it. So negative y, be careful with this, negative y equals 2.5. So what would a y equal? Would you divide by negative 1 or just flip your signs? So y would equal negative 2.5. So let's check that in the second equation. We had just have our x-coordinate plus our y-coordinate should equal negative 3. What's negative 1/2 plus negative 2.5? Yep, x plus y, right? What's negative 1/2 plus negative 2.5? Negative 3, which checks out. Yep, good. Okay, Rose is not here. Ray. Let's get the page up a little bit. All right, Ray, number 4. Are your x and your y terms lined up? Okay, you're noticing that the process is exactly the same every time. Okay, algebra is a lot about process. Once you get that process down, you can solve anything. Okay, so are your x and your y terms lined up? Yes. Do you have a term that cancels out? No. So what do you need to do to one of those equations? You have to flip all the signs of one, which would be essentially what we're doing by multiplying by negative 1. So which one do you want to flip? I would flip the bottom one, right? So you would have, this would change to negative x plus 7y plus 20. Good. Now do you have a term that cancels out? Which one? My x terms cancel. What's 5y plus 7y? 12y. And what's 4 plus 20? Oops, forgot my y in there. Equals 24. So y equals 2. Good. Which equation would you like to plug in with? Top one. Good. 6x plus 5 times, now our y value is 2, equals 4. 6x plus 10 equals 4. How am I going to move that 10 over? Subtract it. So 6x equals negative 6, and x would equal negative 1. Good. Let's check it over here. What is negative 6 times negative 1? 6. What is positive 7 times 2? 14. What's 6 plus 14? 20, and that's what my equation equaled, so that checks out. Okay. That's a good question. So Hope's asking, do I have to use the original equation or the one that I flipped the signs on? You can use either. Okay. So let's go ahead and use the original one. You don't have to do this, I'll just show you. 6x minus 7y equals negative 20. So this would be 6 times negative 1 minus 7 times 2, positive 2, equals negative 20. So I get negative 6 minus 14 equals negative 20. So that still checks out, right? My signs are just opposite. Yeah? It's a good question. Okay. When we move on to page 17, you're actually going to have 4 choices in a lot of cases of which equation you want to plug into. Shane? Yep. Okay, last one, Emilio. So are your x and y terms lined up? Do you have a variable that cancels? Which one? Negative 3y and positive 3y, good. So now what do you have left? 6x equals 36, so x equals 6, good. Which equation do you want to plug into? What? Top one? Okay, so 2 times 6, because 6 is my x value, minus 3y equals 12. What's 2 times 6? 12 minus 3y equals 12. How am I going to move that 12 to the other side? Subtracting it, good. So negative 3y equals 0. What does y have to equal? Can equal, has to equal a number. It's really common that confuses people. Really common. Okay, what will always be? 0 divided by anything equals what? 0. Okay, so let's check the bottom one. 4 times 6 is 24, plus 3 times 0 is 0. What's 0 plus 24? 24. So that checks out. Awesome. The more you do it, is it getting easier? The process is getting... How many of you find elimination much more user-friendly than substitution? I certainly do. Yeah. Now you like substitution more? Oh, see, I think the elimination's shorter than the substitute. That's all right, but that's why there's a choice. You have a choice. Okay, flip to 217, please. So, Carrington. Yeah. So, I'm going to ask you the same questions, okay? But something a little bit different is going to happen. So, are your x and your y terms lined up? Yes. Do you have a variable that cancels? No. Okay. Do you have any variable that's, if we just flip the signs, they would cancel? No. So here I've got a 3 and a 1. That's not going to do anything for me. Here I have a 2 and a 5, and 2 and a negative 5. That's not going to do anything for me. If I was able to multiply an equation by negative 1, do you think there's other numbers that I can multiply my equations by? I can multiply my equations by whatever I want. Whatever I want to multiply them by to make them useful for what I need them to do. What do I need two of my variables to do? Be close. They need to eliminate each other, right? So tell me a number that 3 and 1, pick a variable. Doesn't matter which one. Pick x or y. Okay, tell me a number that 3 and 1 can go into. 3. So if I had a 3, what would I need to cancel that out? I would also need a negative 3, right? How could I get 1 to become negative 3 by multiplication? What would I have to multiply 1 by to get negative 3x? I would have to multiply that entire equation by negative 3. Okay? So the only step that's different is instead of multiplying by negative 1, now you need to choose the number that you're going to multiply your equation by. And it might be one equation, it might be both of them, to get them to eliminate. Okay? So it's just one extra step, but it's not... Does our top equation need to change? Nah, he's fine. Leave him alone. 3x plus 2y equals 0. Now multiply that bottom equation for me by negative 3, Carrington. Here's where you really need to watch your signs. I'm trying to save you hours of frustration. Watch your signs. Ooh, 51. Okay. Another big thing is people will multiply the x and the y and they'll forget about the constant over here. Don't forget about it. It makes a difference. Now, Carrington, do I have two variables that cancel? Yes. Okay. So now, what do you have? What's 2y plus 15y? 17y equals, what's 0 minus 51? Negative 51. And negative 51 divided by 7 is positive or negative? Negative. And 51 divided by 17 is 3. Good. Negative 3. Good. Now how many choices does Carrington have for which equation to plug into? Thank you, Mr. Pollard. Let me try that question again. How many equations do you have a choice of plugging into now? I have 3. I have my original 2 plus the new one that Carrington came up with. So Carrington, 1, 2, or 3, which one would you like to plug into? 1. Okay. So I'm going to plug in, for y, I'm going to plug in negative 3 equals 0. What's 2 times negative 3? Negative 6 equals 0. Add it to the other side. So 3x equals 6, so x equals 2. Okay. Now, which equation do you want to check it with? Because you could triple check it now. When we change both equations, you could quadruple check it. Second one. Okay. Here? That was a 3x minus 6, and then we put the 6 on the other side, and yeah. That's fine. Okay, so let's check it here. What's 1 times 2? 2. What's negative 5 times negative 3? 15. And what's 15 plus 2? Ding. Okay. So what was the only step that was different in that one compared to the ones we've done before? What was the only difference? You had to multiply, right? Why is it doing that? Okay, so let's do number 9. That is as difficult as they are going to get. And let's put it on the back so we have plenty of room to move. So 4x plus 5 equals 6. Actually, we've got room right here. We're fine. 4x, I lied. Okay. So who's it going to be? Oh, Melanie. Hi. Now here's also my advice. Okay. Do you have anything there that's going to cancel out? No. Which variable would you like to cancel out, Melanie? Cancel out the y. So tell me a number that 5 and negative 7 can go into. 35, right? So if I get that to be 35y and negative 35y, will they cancel? They will. My advice to you is write down that number before you start, because then you remember where you're trying to get to. It's like having a map. I need to get over yonder. How do I get there? And then you don't want to get on the street and go, now, wait a minute, where am I going again? Remember that you're going towards 35 and negative 35. Shh. Melanie's advantage to doing that is one is already positive and one's already negative. That's a good one to choose. Okay? So what would you have to multiply 5 by to get 35? By 7. And then what would you have to multiply negative 7 by to get negative 35? 5. Now you just need to multiply both equations, and then you're good to go. So what's 7 times 4x? Melanie? 28x. We already know we need to have 35y. And what's 7 times 6? 42. What's 5 times 6x? 30x. And what is 5 times negative 20? Negative 100. Now are you good to go? Now do you have a variable that cancels? Yes. That's gone. You get 58x equals, conveniently, negative 58x. When you do this process, I don't want the fact that you've got bigger numbers now to deal with to freak you out, because usually they're all going to be bigger, which means your answers are still going to be nice and small. Okay? So this is going to go up on the website and go into you in School Loop so you have it. Stop. Nobody move. To refer to. And